Alright, let's go over patterns and nonlinear functions. So first let's start with a function. What is a function? Well, for a function, we start with an x value, and then we're given a y value. Okay, so the important thing here is that we have at most one y value. So it's possible to not have any y values associated with that x value, but we're not going to have more than one y value associated with it. So if you think of a function kind of like a machine, this is the machine, this is the function machine. We put an x value in, and out comes a y value, or out comes nothing. There's no y value associated with it. But you'll never have two different things come out. So for example, if we put in x is 3, we might get x is 7. If we put in x is 5, we might get that x is 12. But we're not going to get x is 12 or 5. Okay, that's not going to happen. That would not be a function. So let's look at this graphically. So here I have a function. It's not a specific function, just kind of made one up. It's just going to be representative of, well, for displaying what's going on here. So we have x values and we have y values. So for example, when x is -2, we could look up here and see what the y value is. So when x is -2, the y value is 2. So we have -2, 2. Notice that there's only one y value here associated with this x value. We find the y value just by looking at the function and where it is at that point. So similarly, if we look at when x is 2, we just look at see where it is on the graph. We have a y value of -4. So 2, -4. If we look at when x is 4, just see what the y value is for the function there. In this case, it's -2. 4, -2. And when x is 0, we have -1. So 0, -1. So for each x value, there's only one associated y value. That makes this a function. So how do we tell if a function or if a graph is a function or not? Well, an easy way to do it is called the vertical line test. So the way the vertical line test works is we're just going to draw a vertical line anywhere on here. So let's say we draw a vertical line here. So when we look at this, it only crosses the x at one spot. This spot here, the 4, -2. If we draw a vertical line anywhere on here, each vertical line is only going to intersect the function in one spot. And if that happens, that means that this is a function. So let's look at an example of when this doesn't work, or when the graph is not a function. So let's look at this one and let's see if this passes the vertical line test. So if we draw a vertical line here, you see that it only intersects it in one spot. Same thing here. This line only intersects in one spot, and this line only intersects in one spot. So it appears like it's a function until we get to this area. If we draw a vertical line here, we see that it actually intersects in 3 locations. So this is not a function. If we drew the vertical line here, it would intersect in 2 spots, here and here. So still, it's not a function because it only has to violate that rule once. And if we test it here, we see 2 spots, that's more than 1. So again, this is not a function. Let's look at another example. Let's say we have this function. We have a point here, and a point here. It looks something like this. Okay, this is actually the function y equals the square root of x, or I should say the graph. We're going to see if it's a function or not. So let's see, does this pass the vertical line test? Well, anywhere we draw a vertical line, it only intersects in one spot. But what happens over here? It doesn't intersect anywhere. okay? But the rule is that it can't intersect in more than one spot. It's okay if it doesn't intersect at all. This is a function. Because the rule is that for each x value, you have to have at most one y value. So you could have less than one, you could have no y values associated, but you can't have more than one, so this is still a function. Alright, now let's compare linear functions with nonlinear functions. So let's look at a linear function first. Let's say we start off with 1, and then a linear function is going to go or increase at a constant rate. So if we go over 1, let's say we'll go up 2. Then if we go over 1 again, we'll go up another 2. And then go over 1 again, up 2. So we have a function that looks something like this. It's a perfectly straight line. This is a linear function. So now let's look at a nonlinear function. So a nonlinear function is not going to increase at a constant rate. It could be a straight line, and then it might go in a different direction. Maybe it's just totally opposite from that. Maybe we have a straight line, but then it turns up. Maybe it's not straight at all. Maybe it's curved. It could be anything. It could have a lot of curves. If it doesn't go at a straight line consistently, it's not a linear function. So let's look at another example. Let's say that in this example, what we keep doing is we keep on doubling the y value. So we start off at the same point, 0, 1, but then we double it, so we're at 1, 2. But then we get to 2, we double that, so this 2 becomes a 4. Then at the next point, this 4 becomes an 8, and so on. And then you see if you trace this or follow it, it curves upward. And it would go this way if we continued. But this is an example of a nonlinear function. It follows a different rule than a linear function. It doesn't just keep on increasing at a constant rate.